In this video, we are going to talk about area bounded by a curve. So there are two formulas we are going to use in this topic. Formula number one, area between a curve y equal to f of x axis, and the two ordinates x equal to a, x equal to b is given by capital A is equal to the absolute value of integral a to b f of x into dx. Suppose if I want to calculate area between a curve x equal to f of y axis, and the 2 points y equal to a and y equal to b is given by capital A is equal to the absolute value of integral a to b f of y into dy. Let us move to example number 1. Find the area of the region bounded by the curve y equal to 3x minus x power 2 and the x-axis. In this problem, we don't know anything about the point A and the point B. So we have to calculate the upper limit A and lower limit B by using the conditions. So here the curve is given by y equal to 3x minus x power 2. So to find the value of x, let us assume y equal to 0. So if y equal to 0, we have 3x minus x power 2 equal to 0. Taking x as a common factor, we have x times 3 minus x equal to 0. By equating this, we will come to know x equal to 0 or 3 minus x equal to 0. That means x equal to 0 and minus x equal to minus 3, that will give you x equal to 3. So that means x equal to 0 is one of the point and x equal to 3 is the other point. Now using these 2 points in the formula, we have integral 0 to 3 f of x into dx. Since the problem involving the variable x as a function, we have to use this formula f of x into dx. Then by substituting the function and just integrate, we will get the area under the curve. So here the curve is 3x minus x squared into dx. So let me integrate this. First term 3 is constant. Integration of x will give you x squared by 2 minus integration of x power 2 will give you x to the power 3 over 3 between the limits 0 to 3. So first we have to apply the upper limit. So here we have 3 by 2. In place of x, we will substitute the upper limit 3. So we have 3 to the power 2, which is 9. Minus this x also, we have to replace the upper limit 3. That will give you 3 to the power 3. So 3 to the power 3 will give you 27 over 3. When you substitute lower limit, this will become 0. By simplifying this, we will get 9 by 2. And we will write the value as square units because the question is find the area. So the unit of area is square units. So I have concluded that answer for this problem is 9 over 2 square units. Let us see example number 2. Find the area bounded by the line y equal to x, the x-axis, and the lines x equal to minus 2, x equal to 3. So here we have to draw a rough diagram. So this is my x-axis and this is my y-axis. So here the given line is y equal to x. So y equal to x, the line will be like this, passing through the origin, and then we have considered only x-axis with the lines x equal to minus 2 and x equal to 3. So if you draw x equal to minus 2, this will be like this. If you draw x equal to 3, this will be like this. So as you noticed, we have two region of integration. This is my first region of integration and this triangle is my second region of integration. So here in the first region, the integral starting from minus 2 to 0 and my function is x into dx. Then I have to add with the other segment, this segment. In this segment, the value starting from 0 to 3, same function, x into dx. So I have to integrate 2 times. So integration of first one will give you x squared by 2 between minus 2 to 0, plus integration of second one also will give you x squared by 2 but 0 to 3. By substituting the limits, we will get 5 by 2 square units. Remember, whenever you apply integration, whenever you apply the limits, you have to substitute upper limit first, then put a minus sign and then substitute lower limit. Let us move to example number 3. Find the area of the region bounded by the curve y equal to 36 minus x power 2. So we have y equal to square root of 36 minus x power 2. And the condition is it is only on the x-axis. So now I am going to squaring on both sides of the given equation. That will give you y squared equal to the right hand side, the square root will get cancelled. We have 36 minus x power 2. By rearranging this, I will get x to the power 2 plus y to the power 2 equal to 36. In lower classes, we have learned that this is a circle equation with center 0, 0 and radius r. What is the value of r here? The value of r is 6. So this is a circle with center 0, 0 and radius r equal to 6. So that means we will get a circle like this, covering only the x-axis. Okay, so this is x-axis, this is y-axis, and this is a semicircle. So and here this point will be minus 6, 0 and this point will be 6, 0. So we need to calculate the area under this curve. Okay, so that means we use this formula a equal to a to b y into dx. So here my lower limit a takes the value minus 6, my upper limit b takes the value 6. Instead of this y, we will substitute the given value, which is square root of 36 minus x power 2 into dx. Again, in calculus 1, we have learned the integration of this model. Okay, so I am giving the formula here. So integration of square root of a to the power 2 minus x power 2 into dx, that is going to be x by 2 square root of a power 2 minus x power 2 plus a power 2 divided by 2 sine inverse of x by a. So I just compare my function with the formula. So we have a squared minus x squared. So I come to know that a power 2, in place of a power 2 I have 36. In place of x power 2 I have x power 2. So just rearranging this, I will get x by 2 square root of, see the formula here, a squared minus x squared. So in place of a squared I have 36. So let me write 36 minus x power 2 plus a squared divided by 2. So once again for a squared I have 36 by 2 sine inverse of x by a. So that is x by 6. So this whole thing I have to substitute the limit minus 6 to plus 6. So first we will replace this x, and this x by the number 6, by the upper value 6. So you will get 6 by 2 square root of 36 minus x power 2. So x power 2 means 6 power 2, which is 36, plus 36 divided by 2, that will give you 18 sine inverse of x by 6, that is 6 by 6. So this first part of the value is going to be 0 because we have square root of 36 minus 36. So let me rule out this. We have remaining with this one, 18 sine inverse of 6 by 6. What is 6 by 6? Nothing but 1. So we have 18 sine inverse of 1. Then same way, if I substitute lower limit, so we have minus of the lower limit. The lower limit is minus 6. So once again, wherever you have x, you have to replace minus 6. So that will give you minus 18 sine inverse of minus 1. Okay, we know that sine inverse of 1, that is going to be 90. So 90 means it is like pi by 2, and also sine inverse of minus 1 is going to be minus pi by 2. So this sine inverse of 1 I will replace by pi over 2. This sine inverse of minus 1 I will replace by minus pi over 2. By cancelling 2 and 18, this will give you 9. This 2, this side will give you 9. And I have two minus signs here. This minus going to be plus. So we have left with 9 pi plus 9 pi. So 9 pi plus 9 pi, that is going to be 18 pi square units. Let us see one more question. Find the area of the region bounded by the curve y squared equal to 4x, the y-axis, and the line y equal to 3. So y squared equal to 4x is nothing but a parabola open on the right side like this. Okay, so we have a line y equal to 3. So let us uh, draw this in the graph. So we have x-axis, y-axis. We have the graph y squared equal to 4x, and I have a line y equal to 3, something like this. So the area is nothing but this segment, this region, the blue shaded region. So first let me change the given value into x. We have y squared equal to 4x. So from this I will come to know x equal to y squared by 4. Then let me write the formula. So a equal to integral a to b x into dy. So we have a equal to, in place of a we have 0, because the starting point, the origin, this point is going to be 0, and this point is going to be 3. So we have 0 to 3. In place of x I will substitute this value y squared by 4 times dy. So let me take 4 outside. We have remaining with y power 2. Integration of y power 2 will be y power 3 over 3 between the limits 0 to 3. This is 1 by 4. So we have 1 by multiply 4 and 3 will give you 12. So we have remaining with y power 3. By substituting upper limit I will get 3 to the power 3. By substituting lower limit I will get 0. So we have left with 27 by 12. By simplifying this I will get 9 by 4 square units. Let us see one more problem. Find the area of the region bounded by the curve y equal to x squared. So y equal to x squared is again a parabola, but this time it is open up, and we have a line x equal to 5. So let us draw this one. So this is my x-axis, this is my y-axis. We have a parabola open up, and I have a line, let us say x equal to 5. So this is x equal to 5. So this is the region I want to calculate the value. So it's very simple. Just write the formula y equal a equal to a to b y into dx. In place of a we have 0. In place of b we have 5. In place of y substitute the value in the function, which is x squared into dx. Integration of x squared equal to x to the power 3 by 3 between the limits 0 to 5. So we have 5 to the power 3 upon 3 minus 0. 5 to the power 3 will be 125 over 3 square units. So these two problems I will leave you as an exercise question. See you in the next video.